In this topic, we're going to be looking at the surface area of pyramids and cones. So starting at the top here, let's do this try these. Which triangle has a greater area? So remember the area formula for a triangle is 1/2 times the base times the height. And I use these little dots to represent the times symbol. So if we're looking at both of these, they actually both have the same height of 4, but this one here has a bigger base than the second one. So if I were to plug these numbers into the formula, the first one would be bigger because the base is bigger. So I'm going to say both have the same height, but or number 1 there, has a longer base. So it has a greater area. Now let's look at some pyramids and cones. So on canoe trips, Benoit packs 2 pieces of canvas to make this pyramid tent. One piece is for the walls, one is for the square floor. What is the least amount of canvas for the tent? So in order to find that out, we need to figure out the surface area of this tent. So in step number 1 here, we're going to use this formula to determine the total area of the walls. So remember, the area that does not include the base or the top of it, but this one will only have the base since it's a pyramid, that is called the lateral area. So that's only the walls that we're looking at. So the formula we have here is 1/2 times the perimeter of the base times the slant height. Now keep in mind the slant height is different than the regular height. The regular height would be like going from the tip top of this tent here straight down through the tent, right to the middle of the floor. That would be the regular height, but the slant height is the height of the triangle on the outside, that slanted height there. So if we're finding the lateral area, the perimeter of the base is the distance all around the base, and the base here is 10 by 10 by 10 by 10. So the perimeter there is 40 feet, and the slant height they give to us there is 8 feet. So that's the one right here. It's labeled right there. So 8 feet. So we're going to do 1/2 times 40 times 8 in our calculator, and we should get 160 feet squared, or squared feet. Now let's look at what the total surface area of the tent is, including the floor. So we just found what the walls are, or the lateral area, so 160, but we also need to add the area of the base to that. So I'm just going to put here that this is the lateral area. And now we need to find the area of the base. So the base shape is a square. So we're going to have to do length times width for that. So actually we have a little diagram here, 10 and 10. So we're going to do length times width, which is 10 times 10, which is equal to 100. So the base is 100 feet squared, or square feet. So if we add both of those together, we have 260 squared feet for the total surface area of the tent. Therefore, the least amount of canvas that Benoit needs is 260 square feet. Next, let's look at this example here. A red cedar statue of a trout stands outside the Chamber of Commerce in Kamloops, British Columbia. The stand is a metal cone. What area of the metal is needed for the stand and its hidden base? So you can see in the diagram off to the side here, we have a cone that this statue is on. So let's start by finding the area of the circular base of the cone. So that would be everything in here. So remember, the formula for the area of a circle is pi times radius squared. So the radius here they give us is 1.6 meters, 1.6. And remember, radius is halfway across a circle, so that's what they have labeled for us here. So I like doing that 1.6 in my calculator before, the 1.6 squared in my calculator before doing it times pi. So I would have pi times 2.56. Or if I were to calculate that, we would have 8.042 meters squared. So that there is the area of that circle, or of the base of that cone. Next, let's use this formula to calculate the lateral area of the cone. So the lateral area is pi times radius times s, and s here is the slant height of the cone, and r is the radius, just like usual. So remember slant height, and you can see in this diagram up here, they labeled it for us. The slant height is the slanted height up the side, not the regular height of the cone, which would be going straight down from the tip top. So the lateral area is pi times radius times the slant height. So we know the radius there is 1.6, and we know the slant height is 3.0. So if we do pi times 1.6 times 3.0, we are going to get 15.079 meters squared. So finally, let's calculate the total surface area of the cone. So we're going to take this part here, that's the area of the base that we did right at the top here. So for that, we found it was 8.042 meters squared. And then let's add that lateral area to it, which we got 15.079 meters squared. So if we add those two together, we get 23.122 meters squared. So how much metal was used to make the cone? We could say about 23 meters squared of metal was used to make that cone. And finally, in example 2, Amrita's company rents traffic cones. One cone is 28 inches tall and has a base radius of 7 inches. What is its lateral surface area? So for this cone, we need to use the lateral surface area formula, which is pi times radius times the slant height, which we saw up here. So for that, we need the radius, which we have, but we also need the slant height. Now, this is where it gets a little tricky because they gave us how tall the cone is. So they actually gave us the regular height of the pyramid and not the slant height. So here, let's put in some dimensions. Our radius they gave us is 7, so I'm going to put that down here. This is going to go to the center of the circle. And then they gave us the regular height, which is 28. We need to find the slant height, which would be this, in order to solve for that lateral surface area. So that there, that's a question mark, but that is the S that we're looking for. So in order to solve for that, if you notice what I drew on this little diagram here, it actually is a right triangle. So we could use Pythagorean theorem to determine the slant height. So remember, Pythagorean theorem is a squared plus b squared is equal to c squared. So if we label our sides A, B, and C, remember C is always the hypotenuse of the triangle. And in this case, the hypotenuse is the slant side. So I'm going to put a little C there. And then A and B, it doesn't matter which sides they are. So I'm going to put A here and B here. So in this formula here, instead of writing c squared, they put s squared because that's the slant height. That's the side we're looking for. But this is technically like our c. And then here we're doing a squared plus b squared. So let's plug in these numbers. Our a we said is 7, so we're going to do 7 squared, which they have written there. And then we're going to do 28 squared. So if we do 7 squared in our calculator, we get 49. And if we do 28 squared in our calculator, we get 784. So if we add both of those numbers together, 49 plus 784, we get 833 square inches. So now we have s squared, or c squared, is equal to 833 inches squared. But we need to get rid of that little squared next to the c. So what are we going to do to get rid of that? To cancel it out, we need to take the square root of both sides of the equal sign. So that's what they did here. So when we take the square root, we're going to end up with these two things canceling each other out. We're going to get that c is equal to the square root of 833. So that's what they have written in this step here. They like taking shortcuts in this booklet. So I'm going to do the square root of 833 in my calculator, and I get 28.861 inches. So that there is the slant height. Now they want us to calculate the lateral surface area, and now we have every part we need to do that. So pi, that's just a button in our calculator. Then radius, we know is 7. And then we just figured out the slant height, which is 28.861 inches. So if we multiply all of those together, pi times 7 times 28.861, we get 634.702 square inches, or about 635 square inches if we round that up. So the lateral surface area is about 635 inches squared, or square inches. Both of those mean the same thing.